Hi, thank you everyone for joining in. Who's joining us online?
And Andrew, me.
Andrew?
I think that's it.
Anybody else?
Just me, as far as I can tell.
And you can hear us fine?
Yeah, very well.
Fabulous. Well, thank you everyone for coming. Matt is secretly hating the fact that he isn't here. You know, this is his baby, and I want to be here. He will be, I think he'll arrive around 8:30, 9. He's on his way from Portsmouth. He had a job to do there today. But yeah, thank you on behalf of both of us. And today we have my cousin, Jesus. He's a really cool guy. And he has kindly, as you know, agreed to talk to us about artificial intelligence. And I think we just agreed the title for it, Jesus, but I'm going to leave that to you, and I don't want to steal the thunder. So without any further ado, like we say here, Jesus, over to you.
Thank you very much for your very nice presentation, Anna. Thank you so much. You're also awesome and really cool. So thank you, and hello everyone. I feel somehow like the international expansion of the geekery, no? Somehow. I was spending, in fact, the reason why I'm here is that I was spending some weeks in the UK with my family this summer, and then I used the time just to get close to and meet Anna, no? And then we spent a very nice days together. Matt and Anna showed me the geekery. I was totally amazed. My background is as a telecom engineer, despite I never worked as an engineer. I have to recognize that I got really bored when I started my technical work. Then I moved into business. However, I have always had this technical background somehow that I still maintain as a hobby, no? So working for that is something that I have to say I don't like, but I enjoy a lot maintaining that as a hobby, no? So definitely I enjoy that thing that I studied, no? And then Anna and Matt offered me the chance to share with you something that I was learning just before summer, no? And then I decided to accept, and I hope somehow you enjoy this and this is valuable to all of you. Let me share my screen first. Okay, this. And by the way, please, first thing, apologize my English. I know it is far from being perfect. In case you don't understand any of what I say, please let me know. But I will try to do my best, okay? Can you see my screen, please?
Yes. Yeah.
Okay, great, awesome. So just, first, let me talk a bit about myself, but I don't spend a lot of time here. Just to introduce myself to you, know. So why I am here and somehow why I feel like a part of this community, no? So something that I like doing is the kind of totally useless things that nobody else would do, no? My wife sometimes wonders why I spend so much time doing this kind of stuff, and just wondering whether is there any way to take advantage and make money out of that. There is not. But I enjoy a lot the kind of thing that I do, no? Just here sharing just 3 simple examples. Like I think 18 years ago, I spent like 4 years in my life, almost all my spare time doing something which is, it was a point when I wondered if it would be possible to know what the position of the sun would be in the sky at any given day of the year, at any hour in that day, and in any place in the world, no? Because eventually, we know that the year is, all the years are more or less the same thing, and then I wonder, maybe it's possible just to predict where the sun will be, I don't know, in the Netherlands on March 28th at 3 p.m. And eventually I spent 4 years doing maths I still keep a whole notebook full of formulas. And eventually I got to a formula. It's a huge formula. I think 3 or 4 pages, and it worked quite well. So I felt really proud after 4 years of failing, which is something I like very much. Failing, getting up, failing again, and the whole process eventually learning a lot. No, and this is one of the things I feel most proud of. No, despite it's totally useless, because you will find many different apps that will do this for you. No, so once I did that, some years later, I knew that the ancient Greeks managed to know the distance or to calculate the distance between the Earth and the Moon. This was like, I think, 350 years before Christ, without calculators and even without a pencil and a paper. I don't know how they even wrote anything. No, where. Then I thought, well, if the ancient Greeks managed to calculate that, then I should be able to do the same. No, why not? And then I spent a full year. This time I could use what I learned in the previous exercise, and eventually I found a way on myself just to calculate that distance, something of which I also feel very proud. And then, well, last year I decided to take a course on data science. I am a sales manager working at Microsoft, so I don't have a technical role. But as I said, I still keep the taste and the like for technical things. I love numbers. Whenever I see a couple of numbers, I try to match them and to do something with that. It's something that really excites me. And also, as a sales manager, we work with a lot of numbers. And something that I know very well is that when you manage to dig into the numbers and manage them properly, then you find a huge amount of useful information, insights that then you can use to do something else. And well, I usually work a lot with Excel, with Power BI, and eventually, well, that is also even become short to me. I wanted to learn something else, and then I took a course of quite an intense 6-month course in data science. In fact, we were 25 people. Most of them were IT people, programmers, in fact, and I was working with them. No, I enjoyed a lot that course. It was not only about managing data, but also going beyond about machine learning, which is like the introduction to artificial intelligence. And well, while I was there in the UK, enjoying some days with Anna and with Matt, I was sharing this with them, explaining the kind of things I was doing. And they told me, well, maybe you would like to share something of this with our community. And I accepted. And that's the reason why I'm here today with you. So then let me tell you what I will be talking you about today. Today is about how to run a very much classical problem, which is image recognition, which can be done with, well, AI, machine learning. So it's about how we can know whether this picture that we have here in the middle, which, well, we can really easily realize this is a 5, someone, which was me, writing a 5. Well, it is what number is this, no? For a human being, this is really easy because we are very much used to recognizing patterns on a picture, but we are very bad working at numbers, no? And when you have to recognize not just one number, but thousands of them, you need to use a program that will do it for you. So we need to be able to provide to that program some rules that will let them know whether this is a 5 or a 3 or a 4. No? In reality, there are 2 very good examples where this is very useful. One is when you go to the parking lot and then, well, somehow they take a picture and then they print a ticket and you can read on the ticket your plate number. And you may wonder, hey, how did they know what my plate number is? No. The other example is not that nice. It's a bit more unpleasant. It is when you go too fast in the highway and then the policeman takes the picture or the radar takes the picture and then they send to you a very polite note with a fine. No? And then, well, they take the picture of your plate number and then that helps them to identify your car. No? So how do they know? How can they recognize just from a picture what those numbers are? So this is what I will be explaining to you today. I will be spending some time explaining the maths, digamos, the maths or how this is done, and then I will use a Python script to do a demo. I will be running some Python script showing you how this is actually done. By the way, so far, can you understand me well? Or
Yes. Yep.
Oh, great! Thank you so much. In case of any question, please tell me, because I am right now just watching my display, but I cannot see anyone. So just raise your voice and throw away the question. Okay.
I've got a question, but I'll ask it at the end. I've got two questions, in fact.
Okay, if you will.
Yeah.
Okay, as you wish. Then that's a problem, no? Classifying this thing. How is this done with, first thing, what machine learning is about, how this works. I don't know if you are aware of this thing of machine learning or AI or not. This is the intention of this slide is just to provide a very light introduction to some key concepts, no? The idea is the following. With traditional IT, there would be an expert that would be providing the rules to the programmer, no? So imagine we want to recognize whether it's a 5 or a 1. So you would hire an expert that can recognize this, and this person can take, for instance, 2 different features. He could be able to measure, let's say, the width and the length of the picture, and they would say, well, ones usually are very, very narrow and quite low. So usually the width and the length of those ones would be some. And the 5s, in fact, are wider, not very much longer, and they usually are within these values. And then the programmer would be using those parameters just to produce the program. But however, in some cases, those rules are not that easy to extract. The problem may be too complex for anyone to provide any kind of rule. So here is where machine learning becomes really useful. How this works, no? It works in the following way. We need to be able to extract rules from the experience. The experience is what we will be providing through what we call a training data set. A training data set is, in this case, a collection of 1s and 5s where we have been measuring these 2 features that we will be using, the length and the width of all of these 1s and 5s. And from all of these, we will be trying to extract the rules. So a key pillar of the whole thing is the quality of this training data set. You can imagine that if we use a very long and high quality training data set, the outcome would be good. If the training data set is really short and with poor quality, the result of the machine learning model will be also really poor. So training data set is the collection of data that we will be using to extract the rules. Features, which is a key concept as well in AI, is the parameters that we will be using just to identify what we are looking at. Then we will be using what we call an algorithm, and we will be using here a very simple one, in fact, the simplest one. An algorithm will be extracting those rules from the training data set. And once we extract those rules, we will be putting them into a piece of software that we will call a trained model. The trained model, in fact, is what the programmer would have written using the rules provided by someone else. The whole process is what we call the training process. So the training process is about getting a training data set, selecting the features we will be looking at, providing them to an algorithm, the algorithm being able to extract those rules and putting them into a trained model. This is the whole process that we will know as training process. Once we have the trained model, then we can use that. And to that, using this model, we will call making a prediction. A prediction is we provide an input, in this case, this picture with a 5 that we can measure. The length is 3 millimeters, the width is 3.5 millimeters. We provide this to this piece of software, and the output is, well, this is a 5. This is what we call a prediction. And with this, now I will try to, in a very simple way, to explain you what we'll be doing now with the Python code. How we will manage to recognize whether that picture is a 5 or is a 3. How we will do that? Well, first, we will take quite a long training data set. Just for the sake of simplicity, I have simplified here the thing, so we can represent this in this chart. Let's imagine you have, instead of just a training data set with just 10 different numbers, here we only have 4 of them, no? 5s, 1s, 6, and 0s. For each of them, we have some samples where someone has been measuring the length and the width, no? And I have represented here all those numbers. So the challenge here, the problem, the classification problem here is about how we can discriminate where the 5s are, where the 1s are, where the 6s are, and where the 0s are. If we manage to discriminate somehow where they are located, then it will be much easier once someone gives us a new point here in the chart. We will be able to tell whether that's a 5, a 1, a 6, or a 0. No? So for that, we will be using what is very likely the simplest algorithm in AI, which is a linear regression. A linear regression is simply a straight line. So we will be using straight lines just to discriminate here, this. And we will be trying to identify those lines. So imagine that we manage to draw this straight line here, and then by drawing this, we will know, hey, everything that is below the line, very likely, we can call this a 1. Everything that is above the line, we don't know what that will be, but for sure, or very likely, that will not be a 1. Then we can draw this other line. And with this line, we can separate 6 from the others, no? And then we can say, hey, everything that is over here, very likely will be a 6. And everything that is in this other region below the green line, very likely will not be a 6. And then we can draw another straight line, which is this dark blue. And then we can say, hey, everything that is above the dark blue straight line, very likely will be a 5. And everything that is below, very likely will not be a 5. And then last, we can draw this light blue straight line, saying everything at the left very likely will be a 0. Everything at the right very likely will not be a 0. So the whole problem is about identifying which are these straight lines. In reality, if you remember from secondary school, the formula for a straight line is as simple as this thing. So you take x, you multiply that by the slope, and then add the intercept. So these two numbers are the two numbers that the algorithm needs to find. In reality, not just two numbers for just one straight line. But in this case, we need 4 different straight lines, no? Because we are working with 4 groups. So in reality, the algorithm needs to find the 8 numbers. So 2 numbers times 4 straight lines to be able to draw these lines. If we manage to find these 4 lines, then somehow, more or less, we can discriminate all these numbers. Is so far so good? Is this so far clear? Okay, perfect. Yep. So this is what the algorithm will be doing. So finding out what these numbers actually are, no? And then once we find it, then we can check whether the result is good, no? And if we are discriminating correctly all the numbers. And then here it becomes a very important thing, which is in reality, any algorithm in AI or machine learning will not be providing a simple answer, meaning it will not say this is a 5 or this is a 6. No, it will provide a probability. The probability of something being a 5, a 6, a 0, a 4, a 1, and then you decide. Usually, you will take the highest probability, and then you will assign that class to that new item. No? How that probability is assigned? Well, it will depend. Let's imagine we are now putting the focus on this green line, okay? So the farther the item is above the line, the highest probability it will be assigned to be a 6. The farther away at the bottom from the green line, the item would be the lowest probability of this being a 6. So in the infinite over here, probability of being a 6 would be 0. The probability over here of being a 6 would be 100%, would be 1. Here in the middle, in the green line, this would be probability of being a 6 would be 0.5, 50%. No? And same thing with the others. No? With this orange line, the farther away to the bottom from this line, the highest probability of being a 1. The farther away at the top from this line, the lowest probability of being a 1. No? And this is how we will discriminate it. But this creates problems. No? And then you can see here that, in fact, these straight lines are not perfect, because we have some confusing items here. For instance, this dark blue dot. How this will be recognized? This can be either a 5 or a 0 because it belongs to both groups. No? So what the algorithm will do is looking how far it is from both lines, and then it will measure the distance. No? To the light blue straight line, it is in fact closer than to the dark blue line. No? And then because the dark blue line is farther away, then the higher probability that will be. So it will say this is a 5 and this is not a 0. So it will be properly classified. No? However, there may be other items where that is not that easy. In this case, for instance, this dot here is closer to the dark blue line and farther away from the green line. So the algorithm will assign a higher probability of being a 5 than of being a 0. And then it will say that this is a 5 and it is not, no, sorry, it will say it is a 0, no, it is a 6, excuse me, apologies. It is farther from the 6th line, which is the green one, so it will have a higher probability, meaning it will say this is a 6 and it is not a 5, making a mistake, which is this red dot here. This is to explain that nothing is perfect. So the result of the algorithm depends on the quality of the data set. In this case, we have very few points, so we will have mistakes, and also the algorithm that we will be using. In this case, we are using a very simple algorithm, which is a linear regression, and then the result will not be perfect. Of course, there are better algorithms, random forest, neural networks, which will improve the result. But I prefer to use this algorithm because being so simple helps a lot to explain how this actually works, and also to show that in fact nothing is perfect, and that you will find errors in the outcomes of the models, and then here you can understand the reason why for those errors. So if this is right, then I will go before going to the demo, I will tell you what I will do in the demo. So for the demo, I will take a picture. I will just lower the resolution of the picture because we will be working with the data set which is low resolution. And instead of working with the width and the length of the picture, I will just take the grayscale which is assigned to each of these pixels. This will be a picture which is 64 pixels, 8 by 8, each of them with a 16 grayscale. So in reality, this picture becomes this matrix. So instead of using just 2 parameters, like I was doing here, measuring the length and the width of the numbers, I will be taking for each number, I will be taking 64 parameters, each of one representing the value of each of those pixels. Okay? Is
Yeah.
so far so good? Is this?
Yeah.
Yes, yes.
Yeah, okay. So now let me go here, if I can. Okay, here it is. So this is a Jupyter notebook. I don't know if you're familiar with this thing. Are you familiar with what a Jupyter notebook is?
Yes, but for those who aren't, please explain.
Yeah,
Okay,
I've
just
heard
wait.
of them, but I've never used one.
Okay, perfect. So then this is good because then we can make this time useful. So a Jupyter notebook is quite a useful and powerful tool for data scientists. It's a tool that allows you to do 2 things. One is to insert some kind of text. As you can see here we have text, and this is like some sort of LaTeX, more or less like that. So you can write like a Word document where you can type, use, for instance, bold letters, something like that, no? And then also you can also insert Python scripts. So the purpose of this tool, of a Jupyter notebook, is to allow to the data scientist to explore the data. So usually the data scientist will be introducing some comments here explaining what we are doing. I am now exploring this data set. I will cross the table with this thing just to know how many people is doing whatever the thing, no? And then going step by step, inserting a Python code that can be executed within the document. So imagine that you take a Word document, for instance, and within the Word document, you can insert Python code that you can also execute. So in fact, this becomes really powerful to explore data. It is not useful to run a proper script Python, a Python script. Of course you can, but then you don't take advantage of all these tools that you can write things, include graphs, charts, etc. No? So for exploration purposes, this is extremely useful. The tool that I am using for this is Anaconda, that I can show it here to you. This is Anaconda. In fact, this is quite a powerful tool, including a lot of different tools. I am not even aware of what all of this what you can do with all of this. For instance, a spider, this is like some sort of, environment to run Python scripts, for instance. You have also here R, and here you can also use R scripts and run them. Also, Visual Studio Code is integrated here. Well, here it is like the environment from which you will launch your Jupyter notebooks. Apart from this, you can also use Google Colab. Google Colab is also a very powerful tool. Let me Google Colab. If you go here, Google have this is, Anaconda is free, and also Google Colab. Google Colab is an environment that will let you create your own Python scripts, your own Jupyter notebooks. Also, you will be able to run those scripts using a GPU for free. You can book a space in a GPU, and then you can run those Python scripts, which is really powerful indeed. So you can use both, and you will find in the internet plenty of different tools with the same purpose. Now let me go back to the Jupyter notebook. Okay, here we are. So this is now we know what a Jupyter notebook is, which is an environment that will help you to explore data and work with data, not to put anything in production. That's not the purpose of the Jupyter notebook, but for exploration purposes is really good. Then I will explain you what I will be doing now. So first thing, I will be importing some libraries. The libraries that are extremely popular in Python are these 2 ones, NumPy and Pandas. Those are the 2 most basic libraries. for data scientist purposes. That will help you to handle structured data. Basically, tables, the regular Excel file, for instance, you can import that with pandas, and you can work with pandas with that Excel file. It is called, in the pandas language, that is called a data frame. Data frame is like a table with how many columns you want and how many rows you want, no? And then with the pandas functions that are included in this library, you can work and do plenty of things with that Excel file or the CSV file or whatever. You can import many different formats. I will also import, meanwhile, I will be importing them. We'll also import Matplotlib. Matplotlib is a library intended for graphical representations. So if you want to produce a chart, you want to use the data frame, the Excel file, let's say, you import the data Excel file, and then you want to produce some charts. There are many libraries. One of them is Matplotlib, that you can use to produce those charts. By the way, can you recognize the letters, or should I make this bigger?
No, it's fine.
That's
You
fine.
can do it.
Great. And then there is a third very important library, which is sklearn. Sklearn contains a huge number of different machine learning functions, algorithms, metrics, tools. Also there are also some other libraries, but sklearn maybe is one of the most popular libraries for machine learning purposes. So now that I have imported all those libraries, what I will do is I will import a training data set. You will see that this is the text that I wrote. The code in these frames is Python code. In order to run that, I will click here, overrun. Then you will see for a moment an asterisk here. Once the asterisk is changed into a number, means the script has been executed. So I was explaining. Now I will import a data set with a certain number of digits. So someone has been writing by hand some numbers, then taking pictures and lowering the resolution of that. There are many public libraries that you can use for training purposes. You can find some of them in this sklearn library. There is a sublibrary which is datasets, and from there I will be importing load digits. Load digits, you will see it now. It's a library containing almost 2,000 different pictures of people writing handwritten digits, in fact. Besides this, you may find also other training data sets. Pictures from people, for instance, with glasses, without glasses, smiling, feeling upset. Or you can find, for instance, data sets of people having cancer or not having cancer with different features that the doctor was tracking. Plenty of them just to play with them. The main purpose of this is not to do a proper and a serious machine learning model, but just to let you play. This is totally for free. And you can find those data or data sets here in this library, okay? So now we have uploaded the training data set. You can know that we have uploaded almost 1,800 different numbers. Those are the numbers. You can realize that, in fact, the quality of this is not very good. For instance, this is a 6. Well, maybe we can guess this is a 6, but it is not that easy, no? There are others. This one, for instance, this they say is a 7. Well, it's a 7. It could be a 3. It could be anything, no? This over here is an 8. So you can imagine that if we work with a training data set with this low quality, the result will not be very good. And in fact, you will realize, we will be running and doing some demos, you will realize the result is not very good, in fact. But well, just at least you get a taste that by using almost 2,000 different pictures of this quality, you can do something, but it is not very perfect. So we can show, for instance, and we can take one of those numbers and then show the actual values of that matrix. Those are the values of the pixels for one of those zeros. Now what I will do is, once that I have uploaded the training data set, I will train my model. But before training my model, something that it is very common is the following. And this is a rule that everyone will follow. So you take your training data set and you split that into two different pieces. One that will be used for training purposes, just to train your model, meaning you will be using that piece to extract the rules that you want to use, no? And then you will keep aside the remaining part, which we will say, or we will name that as the test piece. Usually, the train part will mean between 70%, 80%, and for the test purposes, we'll maintain between 30 or 20% of them. The intention of this is that you will train your model with this 70%, but then in order to find out how good your model is, you will validate the result not against the items or the pictures you use to train the algorithm, because obviously the result will be good. But you will measure the quality of your model versus those items that you did not use to train the model. So items that your model never saw before. And then by giving to your model totally new items, you will have a better knowledge of how good your model is. So for that, well, we take a function which is called train test split, and then, well, very rapidly you will see that this function has taken all these almost 2,000 different pictures, and it has breaking it down into two different pieces. 70% of them now has been moved to a different data set that we will call train. 30% of them have been moved to a different group, which we will call test. Now we will import our logistic regression algorithm, and this is the line that we will be using to import that. As you can see, we are using this sklearn library, and from here we're importing the logistic regression algorithm. There are many more. Under sklearn, you have, as I said, random forests, neural networks, many of them you can use. So let's import it. Now we have it. And then we will train the algorithm. By training the algorithm, if you remember, it means now when I execute this line, we will be asking the algorithm, this logic regression algorithm, to go through 70% of these 1,800 different pictures and just go through all those pixels and try to extract and to get the best straight lines, meaning these lines, that will better separate the different groups. So now it's about finding these values for these straight lines. But instead of using just 20 items, it's almost 2,000 different items. In fact, this goes super fast. I will execute it now, and you will see that it is really fast. Now it is done. So now we have trained that, and we have found all those 10 straight lines. You can see here that, well, they are 10 lines. In reality, we shouldn't call them proper lines, because a line is something that in a two-dimensional space has 2 parameters, but because we are not working anymore with 10 parameters, but with 64 parameters, because we're taking the pixels, then the dimension is 64. But well, we can call them, they are like hyperplanes in a 64-dimensional space. No? Well, if we are curious, we can find these are the 64 parameters for the straight line that define the zero. So these 64 values will be the equivalent of these values over here. This is the line for the zero. In a two-dimensional space, we have just 2 parameters. But in a 64-dimensional space, we need 64 parameters. No? Once we have trained the model, now we should be curious about how good the model is, no? So let's do first something by hand, which is just taking just one random picture and guessing how it has been classified, no? So now I will take a 7, which is this number, and we will see the probabilities that our model has been able to assign to this number. So we can see that it says that the probability of that number being 0 is 2 times 10 up to minus 11, so nearly 0, no? This probability of being a 1 is something up to minus 9, so nearly 0. And same thing with the others, no? Minus 13, minus 6, minus 12, minus 11, minus 15. But here we find the probability of this being a 7 is almost 1, no? 0.999999204. So what it will say is, well, this very likely, this is a 7. Let me make this a bit bigger. Okay. So we will say the predicted class, and let's see, it says yes. The predicted value for this is a 0. We can even print the shape of that number. This is the real picture we were analyzing. Well, yeah, this could be a 7, no more or less. In reality, they say this was a 7, and the predicted value is a 7, meaning, well, it seems somehow the algorithm is working well, no? We could do this by hand with all the test numbers, but you can imagine that going by hand with such a huge number of numbers is not useful. It cannot be done. So we need to use other metrics and use some functions that we will find. And then we enter into something that is really important, which is measuring the accuracy of our model. A very straightforward way of doing this is importing some functions, which is the score function that will give us one number. In this case, this is saying the accuracy of the model is 96%. What does this mean? This means that this thing has taken the test group of pictures and has run the prediction across all of them and is counting how many of them have been correctly predicted. And it says, well, out of 100% of them, out of 100 of them, 96 were correctly predicted, which is fairly good, no? So only 4% we have failed in them, which is good, no? Of course, we can compare this against the result if we measure the accuracy with the training data set, and you can see that the training data set accuracy is 100%. Well, which is easy to understand because they have been used to train the model. This is why you will never use the training data set to measure the accuracy of your model. And this is why you need to keep apart, to keep aside some other items so you can check and measure the accuracy of your model. However, this is not enough. And what I'm going to explain to you now is something important, which is many times knowing the accuracy is not relevant enough. That will depend on the purpose of your job. Let me show you the following. There is a very powerful tool that we call the confusion matrix. This tool is very common in classification problems. I will explain you how this must be understood. Here, in this axis, we will find which is the real value of each of those images. Some of them will be zeros, ones, fours, nines. And here in the x-axis is the predicted value. So let's work on this. Let's take, for instance, this row, twos. This means for all the twos that we can find in the data set, one of them was predicted to be a 1. So this prediction is wrong. And 52 of them were predicted to be 2, which is really good. for instance, with this thing, with the force, one of the force were predicted to be a 1, which is wrong, no? But 53%, 53 of them were predicted to be force, which is good. This is how we measure, how we understand this. There is a different way of looking at this, which is as follows. For instance, let's take this column. We understand this in this way. For all the numbers that now we predict that they are 5s, in reality, one of them is a 9. So this was a failure. Another of them, in reality, it was a 6. And 52 of them were 5s, which were correctly predicted. So when should we use each of those views? No? Imagine, for instance, that you're a doctor and you're running a model where you're trying to predict who of your patients may have a cancer. No? So definitely you would like to avoid any kind of mistake. No? So if you look at this, let's say the value of 2, let's assume the value of 2 means that this person, in reality, this person has a cancer. No? So this would mean that there is one person with a cancer that we are predicting that this person has not a cancer. This, we are saying this is a 1 instead of a 2. So this is an error. So from the point of view of the doctor, we will want to minimize this thing. We will want the majority of all the real tools to be properly recognized, no? Minimizing the numbers or the values that are in these other columns. So to this measure, to the percentage of tools that are actually correctly predicted, we'll call this recall. This is another metric. And this is what the doctor will try to measure. However, now imagine you are Netflix. Netflix will have a recommendation service, meaning every time you connect to Netflix, they will try to recommend something that you really like. For instance, imagine you like, I don't know, action films, no? And let's suppose action films are classified as 3s, no? So Netflix will want to offer you those films that you really like, and will try to avoid to offer you films that you don't like. So imagine in this case, Netflix will be looking at this differently. Imagine that the 3s are those action movies, no? In this case, those is that we will be classifying those movies, and here we will have one film that has been classified as a 3, as an action movie, that in fact was not an action movie. In fact, this was an 8, that may be a romantic movie, for instance. This means that Netflix would be suggesting to this person to watch a romantic movie, pretending that it's an action movie, which is wrong, no? Also, here we have something which is wrong. A 5, maybe this is, I don't know, a terror film, no? Then Netflix would be advising to this person to watch a terror film, thinking that in fact it was an action movie. So from the point of view of Netflix, the interesting thing is looking at the confusion matrix from this perspective. They are not so much interested on looking at this point, because, for instance, let's look at this. The 3s are the real action movies. Here we have 3 films that has been wrongly classified as something else. Well, in this case, this means they will not be offering this to the customer. Well, the customer in reality will not know that he's missing this film, which is okay. He will not know, that's okay, no? The problem is offering something which is not good. So I don't know if I am being able to make myself clear. The message is, depending on what you're looking at, you may need to use different accuracy measures. That's the important thing. So if this is a bit confusing, forget about that. The important thing is that you get the idea that accuracy measures, there is a lot. There are a lot of them. You need to find out that is relevant to your particular problem. That's the key message that I wanted to communicate here. But maybe I made it too complex. I don't know.
No,
Fine, really good.
It's fine. Okay. So also being so far from you, it's a problem because I cannot just watch your faces and I cannot adjust the message. Apologies. So now let's go with the thing. Now what I will do here, I will do now the magic. So this is my 5 that we were watching at the beginning with the slides. This is the same 5 that you can see here. And then I will be just running the prediction. Before that, as I said, I need to lower the resolution. So this is my 5 in low resolution. Let's see how the model is predicting this thing. Well, it says this is a 5, which is good. So it has worked really well. And now we can see also the probabilities that the model has assigned to this number. For instance, well, you can see probability of being a 0 is like almost nothing, something 10 up to minus 5, minus 10, but probability of being a 5 is 0.994, which is good enough. So we can safely say this is a 5. We can do this with other numbers. For instance, I think I have here where I should upload this to 5. If I put here, I believe I put a 4. Let's upload a 4. This is my 4. Now I will lower the resolution. This is the low resolution version. Let's run the prediction. It still predicts correctly that this is a 4. We can also see the probabilities. Yeah, the probability of being a 4 is really high. But I will show you now that with all the numbers, this doesn't work so good. Now let's take a 6. This is my 6. And I would say that, well, everyone would say this is a 6, no? Isn't it? This doesn't look like anything, anything different, no? We will lower the resolution for this. Still, we can recognize this as a 6, no? But when we run the prediction, it happens, it says this is a 4. And if we look at the probabilities, you can see the probability of being a 6 is really low, 0.018. In fact, it's even higher being a 3, or even being a 2, 0.1, no? Or being a 0, 0.29, no? The highest one is a 4, which is 0.38. So clearly, the algorithm is really confused about this, no? The reason for this, as I said, is because the quality of the training data set is very bad, and also because the algorithm, very likely, it is not the best one. If we had been using here a neural network, for instance, the result would have been really good. But well, the purpose of this precisely was that opposite, to show you that these kind of things are not perfect, and everything depends on how the model has been trained, no? The problem with this number, with this 6, is that, in fact, this 6 is like something like this, no? It's placed in a position of this kind. It's between 2 lines, and definitely is farther away from the wrong lines, making the distinction with the different groups, no? And then just to finish, the last piece of this thing, and something very useful, is once that you have been using this Jupyter notebook to train your model, the last piece is to make it useful, no? Because, well, it is good that we can run a script here and play with the numbers, but if you want to put it in production, you want to sell this model to the police, let's say, so they can recognize the plate numbers of those running really fast in the highway. You cannot give them the Jupyter notebook, no? You need to give them a piece of software. So we need to export this to a piece of software. The way to do this is by using this library, which is Pickle. And by using this, then you can flash all the content into a file, a piece of software. Now it is done, which, well, I have named this under the Geekery PKL, that if I go here, I believe it should, no, it is not over here. It should be over here. Classifier numbers. Yeah, I think it should be over here. The Geekery, here it is. I don't know if you can see it. This is the file that we have exported, no? And then you can make this useful. So now you can share this with anyone, hopefully even sell this to anyone. I wouldn't suggest to sell this model because, as you can see, it's far from being perfect. But well, you can work and make this useful for others, and they can just add this to a website, for instance, taking input from the users and then producing an output that can be useful for someone else. And basically, this is the thing.
Matt literally just arrived.
Yeah.
It's like
Hi, Matt.
Ellie.
I can repeat everything if you want.
Thank you, Jesus. That was
fantastic.
Really, yeah, that was very clear. Really, really good. Jesus, thank you. And I think it was very easy to hear, to understand.
Yeah.
So I think we move on to questions. Shall we start with those online because we cannot see you?
I had a question about, well, it's nothing to do with what you just talked about. It was an early one. I wondered, you did your stuff about the moon. Is there anywhere on Earth you can't see the moon?
So, sorry, say it again. Is there anywhere where we can see the moon?
We can't see the moon, cannot see the moon on Earth. And I'm thinking of somewhere like Antarctica or somewhere like
I don't know, but that's another problem you're throwing away to me that I may tell.
Yeah, if you find out, let me know.
No, you have introduced in my brain a virus, eh? I don't think I will tell my wife, but maybe I know this. That's a very good problem. Now I'm wondering, maybe in the polls, but maybe during some seasons in the polls, maybe. Let's
I'm
think.
glad it wasn't a stupid question.
Predicting the orbit of the moon is really complex.
Yeah.
Oh yeah.
It's very, very complex. Yeah.
It depends which moon you're talking about as well. We have several.
Well, that's another good one.
And I've really enjoyed your talk. I have to say, it was very useful, and there's several things that I'd thought about in the past that I hadn't realised you clarified it. So thank you. It was very, very good.
I'm very happy of that.
Something I wanted to ask was, what's the difference between this, because it's machine learning, what's the difference between this, generative AI, and of course general AI, which is quite different again?
What's the difference? A very good question. So first thing, this is about funding rules to discriminate something. No, this is machine learning. In reality, this what I explained you is more than 50 years old. So this also one of the reasons why AI has become so much popular is because despite all the knowledge that was required to do all this stuff was really very well known, but we didn't have the computing capacity to run all of this. But now the computing capacity is available to almost everyone through the cloud services. And this has boosted all those services and research and all this stuff. No, that's one thing. But apart from that, despite we have more computing capacity, this is still machine learning, and it's considered something like that. Machine learning usually is about what is called structured data. So you have seen that despite I took a picture of something, in reality, I was transforming that into numbers, into a table. So I was taking each picture, I was transforming that into a row with 64 different features, no? And then I was taking like 1,800 different pictures. So eventually what I did is I built a table with 1,800 different rows and 64 columns. This is what is called structured data. That it is very easy to assimilate to an Excel table. So machine learning is about working with structured data, tables, transforming anything into tables. Let's say, for instance, you want to do predictions of what the prices in Airbnb will be for certain apartments with 3 bedrooms and 2 bathrooms, for instance, in London during the summertime. So you can download from Airbnb a huge volume of data, structured data, with different column features, number of bedrooms, season, number of bathrooms, size of the apartment, etc. and that's structured data. When you work with unstructured data, video, music, pictures, text, then it is called AI. So, and for that, you need to use totally different algorithms. Those will be always neural networks. So that's the difference first between machine learning, which is very much traditional, always using structured data, and AI. AI is the next step, which is going beyond structured data, using sounds, video, pictures, text, basically, and using only one kind of algorithms, neural networks. Then you can go beyond that, which is the next step that we are enjoying in this moment, which is generative AI. Generative AI is about producing something, something new. So it is not about, you can compare between analysis and synthesis. Analysis is extracting rules. Synthesis is creating something. In fact, if you have time, I had some other slides, 2 slides, showing how more or less you can generate content, how you can train an algorithm to learn how to produce content. It is a bit more complex, but it's about, if you have time, you can go through that. It can take 10 minutes, but I don't know if you have time. It's about, generative AI producing new content, starting from some input that the user will provide. And then the model will use past experience just to learn how to do things, how to play ping pong, how to produce a picture that is similar to how Van Gogh used to paint, for instance. How it will produce a poem for your wife, something like that. That is called generative AI. And then the next step, which is not yet here, it's called general AI. General AI is going beyond generative AI. Generative AI is about creating things, but its model is very much specialized in producing some single thing. Producing pictures, producing letters, creating a PowerPoint, whatever, General AI is about training a model that can understand anything like a human being and then produce an output as any one of us. So I think someone defined a human being being the difference versus a machine, like someone that can wrote a romantic letter to the wife, make the war, walk the dog, study maths, doing plenty of many different things. Right now, generative AI models, they can only produce one single thing. You have very good ones producing videos, very good one producing pictures, but you don't have just something that can understand anything and produce any kind of result. So it's about, you give to the, I don't know, a problem of physics, and the model would understand and would produce you the result, draw a chart, etc. Or, it's about solving much more complex problems. I don't know if I made myself clear.
Yeah, very much so. Very good.
Yeah.
On the in the example you gave, where you might take a photograph of a car and you pick out the license plate, how would you go about finding the license plate in the picture and then chopping that license plate up into the individual characters so you could feed it into the machine learning algorithm?
Sorry, I didn't get very well the question. So I understood it's about a car, someone taking a picture of the plate, and then?
Yes. So if you took a picture of a car,
yes,
you said you could use these sorts of algorithms to figure out what the digits are on the license plate. But how would you sort of hone in on the license plate, and how would you chop the license plate image up into the individual characters?
Well, that I don't know. But it will be, for sure, first taking the picture of the plate, then running a model, another machine learning, that it's able to identify numbers, random numbers. Just say this is a number or not. It's another classificator. and then they run first the model that will be able to extract the portion of the picture containing the numbers. And
Okay, so
then
almost would it
Hmm?
almost sort of look at lots of different 8x8 sections of the picture and say there is a number or not a number?
Yes,
Okay.
that's right.
So hopefully somewhere it would find a number, and then it might then do some other sort of processing.
That's right. It's going step by step.
Thanks. Please.
Do you use the same computing power for all the examples? I think, for instance, you have the letter I, the number 1. The French write the 1 very much like a 7.
Yeah.
E, as we know, if you turn it upside down, it's a 3. Do you pick out the more ambiguous situations and treat those separately with more computing?
What is the question about if we are using the same computing power for each digit?
Do you subdivide the problem to narrow down? Because a 0 is almost universally identified as either a 0 or a letter O, whereas and a B and 8 have ambiguity, but there are some characters that, especially when you take into account different cultures, they have a lot more complexity.
Yeah.
So do you subdivide the problem and treat those differently?
The answer to that is I don't know, because I'm not an expert on that. I just learned how to train the model and make it, no? I assume it can be done, no? It's a good way, just when you're facing complex problems, subdividing them into simpler ones and then approaching them separately when they require different resources can be quite smart, no? But I don't know if they actually do that at all. I suppose they don't. For these kind of purposes, I don't think, because eventually, well, the model is not very complex. So for this purpose, it's not very complex. If, as you say, for some kind of different countries using different alphabets, where characters are maybe more confusing, some between the others, etc., it may be a good approach. But I wouldn't be able to tell you how they approach the thing.
Okay.
I have a question. So you mentioned Google. That means that the algorithms were built by American people. Is machine learning conditioned by which culture produces the algorithms? Will algorithms be different for Western versus?
Well, a good question. Well, in fact, I wouldn't say the algorithm, but the model, yes, will be, because the model depends on the training data set. And then that depends on who provides the training data set and which is the source for that. No? So if you imagine these numbers, no? For sure, the characters will be different. No, this is our Western characters, let's say. No, if you go to any other country, maybe China, they have the use of the characters. No, so this is why you need to feed the model with plenty of different stuff. Otherwise, the model eventually will be biased. And we have, in fact, read in the news at the very beginning a lot of problems coming from this, from Copilot in Microsoft, from Google, from others, providing even, in fact, nasty answers, no? Because they had been trained with not very complete training data sets, no? That were, in fact, biased, no? For instance, towards males or females or some kind of ethnics. And this is, in fact, this is one of the most relevant problems nowadays, no? Because if you want to offer to the world, to the customers, something that works well, you need to ensure that you have been training those models properly and taking a lot of care of that. And nowadays, it's one of the biggest problems, and there are a lot of people really focused on ensuring that the models are trained considering everything that needs to be taken in consideration. This, of course, is not always perfect. There will always be some gaps, and it will be Unfortunately, will be the users who will find out, no? And then they will have to be corrected. Also, by the way, something very common with these models is that they are usually retrained from time to time, no? When, imagine, I don't know, a credit scoring model that is being used by a bank. A bank using a model just to discriminate to whom they are granting a mortgage. Well, they will learn by experience. Maybe they granted a mortgage to someone that met the requirements from the model, but eventually that person didn't return the mortgage, no? Then they will be using that information that with more like that, just to retrain the model so they can learn more from experience, no? So exactly like this happens with any model usually. Yeah? They will retrain the models from time to time, so they improve the results and they become more accurate.
So data is overridden by the newest.
Yes.
And what happens to the waste? So all those cases where the results were not satisfactory, would you call, is that the correct term, waste? Or do we store everything or
Yes. For instance, if you use these models, I don't know if you have been using Copilot, which is for free in Microsoft. You go to our browser, Edge. In the upper right corner, you will find an icon, which is Copilot. It opens the service, no? Then you submit a query, you get the result, and then you will see that very often Copilot will ask you, is this good for you? And then you will say yes or no. You can say it or not, but you will say yes or no. And then Copilot will save that information. And then they will keep that. Then eventually accumulating a large number of feedback from the users, they will gather a huge number of people saying, the answer was good for me, these answers were not good for me. And then they will be using the good ones and the waste, as you say, just to correct the model and retrain the model again. This is very common in any AI service. So asking you afterwards, once they deliver the result, asking you if you are happy with it or not. So then they realize they know what is waste and what was a useful answer.
Thank you. Any more questions? Sorry?
No, very interesting.
No, it's very interesting.
Right.
Thank you. I feel really proud of being part of this community, even from far away from you. I feel close to you.
I was going to ask you, what is your next big thing to learn? But I know Gabriela is going to be saying,
I will not say it too loud, so she doesn't know.
Lunar distances.
Yeah, well, now I will think about this thing about from which part of the globe you cannot see the moon at certain days. I will give it a thought.
that's brilliant.
Thank you for the idea.
Thank you.
Thank you.
Wonderful. Thank you.
Thank you.
Thank you very much to all of you. Take care and good night.
Lovely talk. Thank you.
Bye-bye.
Did you still get
Oh yes,
Speaker.
yes. Hang on a minute. Yes,
Oh,
I've got yes. So there we go. This is for you.
Yes, it's
For all the-
Thank you so much.
it'll be
Unique, cannot be bought in the shops.
Great,
That's
great. So Anna, please bring it to me when you come to Spain now in spring. Bring it to me, please. I will keep it with me.
I was
Lovely.
about to say that you'll have the pleasure to receive it straight from the hands of Matt.
Okay.
What a privilege, right?
It will be an honor.
Thank you very much, Susan.
Okay.
Thank you very much. Take care.
Take
Bye.
care.
Carry on. Bye bye.
Bye bye.